Hi everyone, my name's Gaurav and I'm one of the field engineers at SUSE. I am based out of Melbourne, Australia, and today I'll be walking you through Rancher continuous delivery and how you can use continuous delivery to perform GitOps at scale. So let's dive right into it. Uh, as you can see, I have a Rancher instance running, which is managing a few Kubernetes clusters across different cloud providers. If I had to deploy a workload, say using Helm, I would probably just have a Helm chart packaged, and in a more traditional deployment, I would use Helm charts. So let's take you through a traditional deployment, and then we'll see how we can accomplish the same using continuous delivery. So if I wanted to deploy a Helm chart on a target cluster within Rancher, I'd go to Cluster Explorer, go to Apps and Marketplace. Within Apps and Marketplace, I've already added a Git repo, which contains a client-server app I have created specifically for the purpose of this demonstration. If I wanted to deploy either of these charts, I would probably just click through on the chart, choose a namespace, override any value settings if I needed to, and just click install. And then Rancher would take over, run a Helm deploy to sort of deploy this Helm chart to that target cluster. So pretty straightforward. And as you can see, my chart is deployed. Similarly, using the same logic, I can deploy in Rancher inbuilt integrations, say monitoring, logging to the said target cluster. So again, all these integrations are also Helm charts, which is a key thing to remember because we will be able to reuse this in our continuous delivery-based deployments. So if I wanted to deploy, say, monitoring using Prometheus operator on my target cluster, I would choose the monitoring app and click install. And within a few minutes, Rancher would have deployed monitoring, backed by Prometheus operator on your target cluster. So as you can see, it's pretty simple to consume Helm charts. But at the same time, if you are running lots of Kubernetes clusters, or you're like me who has Kubernetes clusters which themselves are ephemeral, I only sort of spin them up to test stuff and then blow them away. But I want to be able to restore the cluster to the exact state, then I can use something like continuous delivery to define the state of my cluster in a Git repo, and then use labels to deploy all the apps to the new cluster that gets provisioned by me. So we'll just wait for this Prometheus operator to be installed, or monitoring stack to be installed on this target cluster, and that should just take another minute or two. All right, so monitoring is installed on this target cluster. If I needed to access the said monitoring, I can come in here, click on the monitoring menu, and access Prometheus Grafana through monitoring. So this is all nice and fine, but it doesn't really scale out to lots of clusters, as I mentioned before. So if I wanted to manage lots of clusters in one go, then I would look at continuous delivery. So I have, for the purpose of this demo, a few K3s clusters over here, and another RKE based cluster which I'll be using to host the client and server demo, as well as the traditional monitoring logging stacks that we have. So to dive into continuous delivery, go to any cluster in Cluster Explorer and select the continuous delivery option. Within continuous delivery, we see a couple of workspaces. These are basically Kubernetes namespaces that exist on your Rancher cluster, the local cluster, as most people call it. And these can be used to organize your clusters and then eventually do RBAC based on namespaces. Within continuous delivery, we have three core concepts. So one is the Git repo. So this is where you would define a Git repo which contains your deployment manifests. These could be vanilla YAMLs, customized templates, or Helm charts. And these Git repos can then be targeted to individual clusters, which you can see here. So these are all the clusters that Rancher is managing at the moment. Or the Git repo can also be targeted to cluster groups. So cluster groups are nothing but a grouping of clusters based on labels. So within Rancher, each cluster is a Kubernetes object, and like any Kubernetes object, you can have labels, and we can organize clusters into groups by adding the same set of labels. So for example, for this purpose of this demo, I'll be using cluster groups to perform all my actions. So let's get started. So the first thing I want to do is deploy monitoring and logging to my Linode cluster. So for that, I will create a couple of cluster groups. So the first cluster group will be called monitoring. And this monitoring group is looking for a label monitoring enabled on all my clusters. So you can see it's already found one cluster which matches this rule. Now I'll create another cluster group called logging, because I want to deploy our logging stack as well. And for this one, I'll be looking for a key called logging equal to enabled. And again, we have a cluster which has the correct labels and it matches that group. So I can click create, and it's as simple as that. So if I now look at my cluster group settings, I can see that monitoring has one member and logging also has one member. So now let's get down to deploying a Git repo. So for the purpose of this demo, I have taken all the Rancher built integrations and have packaged them up as fleet bundles. So I have the monitoring CRD Helm chart and the monitoring chart. So if we look through, the specification is just a fleet YAML. And within this, I'm specifying, what Helm chart to install. So in this case, which namespace to go to, the release name, the repo where the charts exist, the name of the chart, the version. Apart from that, just for the purpose of this demo, I'm also customizing my Helm chart. So the idea is if you have a Helm chart, you can do customizations on the Helm chart as well. And again, using labels, you can patch up those, values on a per label basis as well. So you could have a superset of values and then, apply subsets or overrides based on a subset of labels on top of that, which makes it really powerful to deploy the same application with certain customizations across a wide variety of clusters. So if I go back to my Fleet UI, I will create a Git repo here, and this will be called monitoring. I'll specify the URL where the manifests exist. In this case, my bundle spec, and I will specify the paths where it will find the manifests. So I have two paths, monitoring CRD and monitoring. And now is the important part, where do you wish to target this deployment to? So I can target monitoring to all the clusters that Rancher is managing, an individual cluster, or a group of clusters based on labels. So I'll choose the monitoring cluster group and click create. It's as simple as this. So now the Git operator, which is also part of continuous delivery, takes over, it checks out the code, and then uses Fleet to create some bundles, which then get deployed to the target clusters, which in this case would be my Linode cluster. It will error out because I have to deploy two Helm charts. One is a chart for the CRD and one that consumes the CRD. So, eventually Kubernetes eventual consistency comes into play, and it will come along and retry and, redeploy the chart once the CRDs are done. So give it a few seconds and we will have monitoring deployed to your target cluster. So again, the same operation that we performed from the UI, but now done, using continuous delivery. And the benefit of this is, or if I wanted to, extend monitoring to multiple clusters, all I need to do is add the correct labels on those clusters, and my monitoring, stack would be deployed to that said cluster. So we'll just give it a few seconds, and as you can see, it's reconciled, it's redeployed, and now the deployments are being created on my target cluster. So this should take a few more seconds. While we wait for this, I will kick off deployment of the logging stack as well to my logging cluster group. So again, similarly, just create a Git repo, provide it a name, the location where it'll find the manifests, and I'll add the paths. And, the last step is choose the targets. Again, I'm going to choose the cluster group called logging, click create, and again, the Git operator will kick in and it'll go about deploying logging stack to the target group, which is the logging cluster group. So as you can see, monitoring is already deployed. Logging will go through the same process as well. It needs to deploy two charts, the CRD, and then the operator, which runs off those CRDs, so a few more minutes, and we should have logging deployed as well. So if I go to my other tab and go to Cluster Explorer, choose my Linode cluster, which is part of that logging and monitoring cluster group, I can see that now monitoring and logging are deployed to this cluster. Similarly, I'm also going to deploy a logging stack using Loki, like a log aggregation endpoint. So again, I'll give the repo a name, specify where to find the manifests for Loki. So I have another Git repo called user bundles in here. I already have a fleet YAML which defines the installation of Loki, and I'm just going to use the same. So back to this, and I can choose a path. The path is called Loki, and I am going to choose my cluster group. So I wish to install it again to the logging cluster group only because I have all the other logging, integrations already available there. Click create, and it's as simple as that. And now Loki will get deployed to my target cluster group. So let's see what's going on there. Oops, I did make a minor mistake, which we can fix, or I can just recreate it. Here we go. All right, Loki attempt 2. It's called user bundles, and I've missed the S, the path, and the cluster groups. All right, click create, and that will trigger the deployment of Loki onto my cluster. So as part of the deployment of the monitoring stack, I already added a data source for Loki, so I can use Grafana to search for logs in Loki. I've deployed a logging stack, which deploys the Banzai Cloud's logging operator, which will ship all the logs to this Loki integration. And all I now need is the application to be deployed to my backend server, which is the API server. And then I'll deploy the API client on a few nodes. So let's get started. So again, I'll go back to cluster groups. I already have a group called API server, which has the Linode cluster, which is where I want to target my backend apps to run. So I'll create the API server get repo, object. I created a separate project for this, just a simple client server app to be deployed using Fleet or native Helm charts. In there, I have a path named charts and server, which is just a Helm chart, and I will target it to a cluster group called API server. And that's it. Click create, and now this will deploy, a simple workload to the said cluster. So we'll just give it a second while it just reconciles the state and deploys the workloads. All right, so now it's kicking through. If I go back to my dashboard, I can look at my deployment. So I can see the API server just got created. Here's the stateful set for Loki, which I deployed to this cluster, which will be used for logging shortly. So, all right, so we've deployed monitoring, logging, we've deployed an API server, which also has the logging integration. So for example, if I go back here and I look at the logging, stack, I have created a flow, which is sending the logs of my API server to the Loki integration that I just installed. And it's, again, a combination of flows and outputs, which sends the information to Loki in the same cluster. So now we are ready to deploy our API client. So before I do that, I need to assign the clusters to the group. So I have these three, edge clusters, which I'm going to deploy, to. So I want to assign them to the correct cluster. So assigning clusters to a cluster group is pretty straightforward. So in my case, the API client cluster group is looking for one label called API client enabled. I can also pass information to my Helm charts using labels. So I can use labels to pass values to Helm charts. So I also will pass an endpoint of where to find the API endpoint. It's, again, pretty straightforward. The API endpoint is the label name, and this is the value where I want to send the, where my API server is listening for requests. So I'll click apply, and that triggers the deployment of, or the addition of the K3S clusters to my cluster group, which is the, API client. So now I'm ready to deploy the API client. Again, pretty straightforward. API demo is the name, and the path is charts client, and I will deploy it to API client and click create. And again, now continuous delivery in this particular case is going to deploy the same app to multiple K3S clusters. So we'll just give it a second, and we'll see the same app getting deployed to my 3 K3S clusters in this particular case. So a few more seconds before the reconciliation kicks in. Let me just make sure all the clusters are available in the group. All right. Okay, we can add the clusters again to the cluster group. That's pretty straightforward. API client enabled, and click apply, and that should trigger the redeployment. All right, so now I've added the correct labels and it's deploying the front-end app that I had specifically written for the purpose of this demo. So if I go to my Git repos, I can see the API client has been deployed to these 3 clusters. Within the apps, they're just sort of doing a random, sleep and sending a payload to my server application. So if I go to my edge clusters, just to see the workload, I can look at my workloads right here. I have a deployment, which is my client, and I can then click through and look at the logs. So again, pretty straightforward, just a randomized sleep, sending a sequence number of the message and the cluster identifier, which is the name of the cluster, to my target server. So if I go back to my Linode cluster, which is running the backend server, I can now come through here, look at my deployments, and again, here's my backend server. Which is receiving all the requests. And I can view the logs. So you can see all the different 3 clusters that I have in the front-end group pumping the information down to this backend service. And I can now, look at the logging as well. So because I deployed Loki and exposed it, added it as a data source to Grafana as part of the monitoring stack installation. So I can actually, browse using LogQL and Grafana as well. So now back to this, we can choose Loki. I know my workload runs in the default namespace, and click run query. And as you can see, all the logs being shipped out to me. So this is really useful, right? And now hopefully it helps you understand the power of, continuous delivery. So for example, if I had a new cluster, provisioned, all I needed to do was add the correct labels. So for example, I have a few more clusters around. So if I wish to deploy the same app to those clusters, all I have to do is choose the clusters and assign them the correct labels. So the label would be API client enabled, API endpoint, which is this, and I click apply, and now I've rolled out the same app to 2 more clusters, which is where continuous delivery shines. It really makes it easy to manage workloads at scale, and hopefully allowing you to treat your Kubernetes clusters as cattle as well. So if I look at this here, I should start seeing, let's say, the results from my new cluster pop through as well. Let me just refresh this. So we can see the Metal 3 clusters come through as well. And I should be able to shortly see the other VMware cluster as well, where I had deployed the same workload. So again, very simple to set up, and hopefully, this gives you an idea on how to sort of, leverage continuous delivery to sort of, perform operations at scale using Git repos. Thank you very much, and I hope you enjoyed this demo.